Hi, this is Anirudh, and in today's video we'll be discussing problems on voltages and resistances as a part of current electricity. Please do follow us on our Facebook, Instagram and Telegram channels for your daily dose of math and physics. Let's get started with our JEE problems. So for the first question today we have a JEE mains question. The supply voltage to a room is 120 volt, the resistance of the lead wires is 6 ohms. A 6 watt bulb is already switched on. What is the decrease of voltage across the bulb when a 240 watt heater is switched on in parallel to the bulb? So first target, when we have two appliances given in wattage, is to find the resistance of that. Let's find the resistance of the heater. That is given by V square by the power. That is 120 square divided by the power of the heater, that is 240. That would give me, if I cut from here, you would be getting it as 60 ohm. Next is to find the resistance of the bulb. Again, V square by the power. V square is again 120 square. The power of the bulb is 60. If you put it in there, you would be getting it as 240 ohms. Now in the beginning you just have the bulb in series with the lead wires attached to the voltage. Therefore the current through the bulb is given by V by the total resistance R, that is 120 divided by the total resistance, that is bulb resistance 240 plus lead wire resistance 6 ohm. So 246 amperes. Therefore the voltage across the bulb is given by IB into RB, that is 120 into 240 divided by 246. Next, when we connect the bulb in parallel to the heater, the resistance of the parallel circuit is given by 240 into 60 divided by 240 plus 60. That would give us, this would give me a 240 into 60 divided by 300, cancels out with 5. When we cut 240 by 5, we get 48. So that gives me 48 ohms. This parallel is in series with again the lead wires of 6 ohms. Therefore the total current with the bulb and the heater in this case is the voltage 120 divided by the total resistance, that is 48 ohm from the combination of the bulb and the heater, plus the 6 ohm of the lead wires. So we have 120 divided by 54 ampere. Therefore the voltage across the bulb or the heater remains the same since they are in parallel, is given by IBH into R parallel, that is equal to 120 into 48 divided by 54. We need to find the difference between these two. If we do that, the change in potential VB minus VBH, we just put the values in. If you calculate the values and put the values in, you will get it at roughly 10.04, as near about 10 if you approximate the values. So our correct option is option number 4. Let's move on to the next sum. For the next problem, we have an ammeter problem. It says a circuit contains an ammeter, a battery of 30 volts and a resistance of 40.8 ohm, all connected in series. If the ammeter has a coil of resistance 480 ohms and a shunt of 20 ohm, the reading in the ammeter will be. So our first target, we know that a shunt is connected in parallel with the basic ammeter galvanometer. So the 480 ohm and the 20 ohm are in parallel. So our equivalent resistance of the ammeter is the parallel resistance, that is 480 into 20 divided by 480 plus 20. That gives me 480 into 20 divided by 500. You can cancel it out. and this would give you approximately 48. This I can make it as 4, can make this as 10. 48 into 4 would give you 192. So 192 will give you 19.2 ohms. This is the equivalent resistance of the ammeter part of the circuit. Now this ammeter part of the circuit is attached with a resistance in series. So the total resistance of the circuit now becomes 40.8 plus 19.2 from the ammeter, that is 60 ohms. So the current flowing through this, the voltage is given, the current flowing this is just V by R. V is 30, the R we just found is 60 ohms, so that gives us 0.5 ampere. Now remember, the 0.5 ampere enters into the entire ammeter circuit. We no longer need to find the current going through only the ammeter part, because the ammeter measurement will give the entire ammeter circuit current. So a correct option is option number 2. This is an example of a sum which a lot of students make a mistake in, even though it is easy, because you tend to overlook a few facts. So it says that A, B, C are voltmeters of resistance R, 1.5 R and 3 R respectively, as shown in figure. When some potential difference is applied between X and Y, that is the ends, the voltmeter readings are VA, VB and VC respectively. Then we need to find the relation. Now most students at first glance seeing the circuit would say that VB is equal to VC, which is not equal to VA, because we know that in parallel the voltages are same and in series the voltage is different. But in this case, if you put the values of the resistances with 1.5 R and 3 R in B and C, then we see that the equivalent resistance of this entire circuit becomes 1.5 R into 3 R divided by 1.5 R plus 3 R, that is 4.5 R square by 4.5 R. So cancel out and you just have R. So the equivalent resistance of this is the same as the equivalent resistance of this, which is just R. Hence, if the same current flows through this, both of these voltages will be the same. That means the voltage of A, voltage of B and the voltage of C will remain the same. So correct option is option number 1. So this is where you need to actually look at the values and not jump to conclusions too quickly. Next week, next video, we will be doing more circuit theory, where we'll be doing Kirchhoff's law and so much. That's all we have today. I'll see you again in the next video. Like, comment and subscribe to our YouTube channel Mathophy for your daily dose of math and physics.